Hello, my dears. Here we are back for part 2 of Mr. M's new way to measure time. Now, actually, that's a strange title. It's not really my new way to measure time. I wish I were the inventor of this crazy idea, or the first person to think of it. I was not. I did mention in my last video the name of the person who did think of this new idea. Do you remember the name? Max Hetzel. Now, Max Hetzel at the time worked for a company named Bulova, and his job was to find a new way to make a watch fabulously accurate. Because, as I mentioned to you before last time, there are some cases in this crazy world of ours where the accuracy of timekeeping is extremely important, perhaps a matter of life and death. I'll play a little video for you in a moment that will demonstrate that. Now, where were we when last we met? Well, when last we met, I assured you that the method Hetzel came up with was to use sound. I'm going to show that to you one more time. Here's my crazy pasta tong or pickle tong. I'll use it as a tuning fork. Here, I'll smack it against the table. Whoop. There we go. Now look at how far back and forth those crazy things go. Oh, that's pretty impressive. But that's a fairly large device, as you can see. I'll try a smaller one here. My little pair of tweezers, much smaller. Here we go. There they go back and forth too. Do you see that? Oh, nice. You can see them very well. Oh. There they go. Alrighty. So if I have a larger tuning fork, my tines, my little forky parts of the tuning fork, go back quite a bit, back and forth quite a bit. And if I have a smaller tuning fork, of course, they will go back and forth a little bit less. Well, if I'm going to use sound to time my watch, I'm going to have to get a tuning fork that's small enough to fit inside a watch. It's going to be a pretty small tuning fork. Is it possible to make one? Absolutely it is. You can just shrink one down and make a tuning fork small enough to fit inside a wristwatch. But wait a second. If the smaller the tuning fork, the smaller the vibration, I'm going to have a bit of a problem, aren't I? I sure am. Well, I mean, how's it going to work? If I have a tiny tuning fork that I can design so that it fits inside a wristwatch, and then over here, I've got the gears of the watch that go round, and they eventually push the hands and show me a different time with my hands. Here's the interesting question. What is going to go in the middle? I mean, this is a great idea. The hands have to go around by all these gears to show the time. And then the tuning fork here is what's going to time them, because the vibrations of that tuning fork never change and they're always the same. But here's the question. What goes here? How do I connect the tuning fork to the gears? Oh, that was Max's next big problem. I mean, what could it be? Is there like a miniature camera that goes in between that can photograph the vibrations and count the vibrations? Or is there some little funny marking device that can mark the vibrations back and forth and count them and tell the gears when to move? I mean, how's that going to work? Oh, he thought and he thought and he thought. And then, like the best geniuses, he was brave enough to come up with an answer which is perhaps the most brave and bold answer any inventor can come up with. It's genius. What goes in the middle between the tuning fork and the gears? The answer? Nothing. Absolutely nothing. You don't have to have any sort of extra machine in between the two. Why not make the vibrations actually push the gears? That's right. The sound smacks into the gears and pushes the gears directly. And unbelievably, that was the idea he had, and that was the idea he got to work. And I'm going to show you exactly how he did it. Just like that. What he did was so incredibly simple. He just took a little pin and he pinned it to the side of one of those tuning fork arms, and on the side of that pin, he put a little rod of metal. Now that rod of metal, of course, is extraordinarily small. You'll see in a moment it's actually thinner than a human hair. On the end of the rod, he put a little piece of ruby, very, very hard, almost impossible to wear it out. And then beside that, he put a little gear. Now you think about that. As this arm goes back and forth, wobble, 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 vibrate, 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 what it does is it shoves, 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 shoves that little arm. And every time it shoves that arm, it shoves the gear one position. Now, you might say to yourself, okay, that actually is really smart. But I thought we said that the smaller the tuning fork, the smaller the vibration. How tiny must the shoves be? And the answer is, the shoves are so incredibly tiny, you can't even see them with the naked eye. You can hear them, but you can't see them. And that's why, as part of the design of this watch, they did something which was an absolute miracle. The invention of this little gear. Now, I've drawn this much larger, of course, to show you how it worked exactly. But I'll show you down on the page here, a picture of the actual size of that gear. That's the actual size of that gear right here. The actual size of that gear is 2.4 millimeters across. If you look at the tip of a pen, you'll see that it's absolutely minuscule. And not only that, it was one of the finest gears. Well, really, at the time, it was the finest gear ever produced. It was 2.4 millimeters across, and unbelievably, on that gear, there were 320 teeth. Can you imagine? 320 separate teeth on a gear that size. How big were the teeth? Each tooth was decimal 0.1 millimeters high, which, of course, you know your decimals now. Decimal, of course, is less than 1, which means this place is the 10th place, which means this place is the 100th place, which means each tooth on that gear was 1/100th of a millimeter tall. How tall is that? It's 1/4 of a human hair. That's right. Each one of the teeth on that gear are 1/4 the size, or the 1/4 the width of a human hair. So that means if you took a human hair and you cut it in half, and you cut each of those halves in half again, one of those pieces, 1/4 of a human hair, is the size of the teeth on that gear. That gear is so tiny and fragile that if you were to pick that up with your hands, you would destroy it. The only way to touch it is to touch it by the edges, the little pins that support it. Absolutely incredible. So now, let's cut to the chase, as they say. Let's take a look at one. Of course I've got one for you. Look at this. On the desk in front of you, I've got some older watches. I've already showed you that one. That's a very old pocket watch, not a very good one. Here we have, unbelievably, a men's model of a Bulova Accutron. I've worn that to school. You've seen me wear that. I'm not sure if you noticed. And here's a, unbelievably, they even made a smaller one. Here's a ladies' model. Incredible. And in front of you here upside down is one that I brought along to show you exactly, because it is, I have the back off it. And look, there it is. Exactly what we've talked about. Now, some of the parts you can't see. Some of those, so the bottom part of the arms right here is a little bit difficult to see. But do you see the top? There's the top of the tuning fork right there. There are the two sides. And I'll zoom in on this so you can have a look at that. Can you see them vibrating? Answer, no, you can't. The vibration is so absolutely tiny that you can't see it with the naked eye, but it is vibrating. And in a moment, I'll prove it to you, because it vibrates at a frequency of 360 hertz. That's 360 vibrations per second, which means we can actually hear that. So in a moment, I'm going to bring it forward to the mic, and you'll be able to hear the sound of that watch running. Now, if you look closely before I get to the sound, oh, let me see if I can zoom in a little bit. Oh, there. Oh, that's very, very good. Oh, you can see some of the gears working. This is the, okay, where am I? Okay, here we are. There's the, underneath here is a second wheel, and it is working now. It's being driven by the one underneath here, and that's the little tiny one. Underneath this little red dot is the tiny one. And if you look carefully, you'll see that very, very slender little rod of metal there. It's actually two of them right there. And those are the pusher rods that I drew for you a moment ago. Isn't that incredible? So that watch right now is actually running. So what I'll do is I'll zoom back out. Now look, I'm going to pick it up and I'm going to hold that watch up to the microphone, and I want you to listen carefully. Oh, I don't know if you heard that, but I sure hope you heard that sound. The sound of the vibrations of that Accutron. Okay, now time for a little video. I promised you that I was going to show you why it's so important to have this crazy watch as accurate as it is. Okay, look at this. What is it? Well, this is a video of the Apollo astronauts as they are coming down from the control module in the lunar lander, coming down to land on the moon. Now, what happened? Well, they took off from Earth a few days before this, and they flew up on the rocket. Of course, it was losing all its pieces here and there. And they get up in their control module. On the side of the control module is this crazy little lunar lander. It just fits two astronauts. They squeeze in there. It blasts off away from the control module, which stays up above the moon, and it blasts down to the surface of the moon. Now, how does it do that? With little tiny retro rockets and a little tiny precise amount of fuel. Now, what the astronauts inside here have to do is they have to light that fuel and blast those rockets off at exactly the right time so they don't wipe out and kill themselves. How did they time it? Well, I guess you know the answer to that, don't you? The Gemini rocket program, the Apollo rocket program, the A-12 reconnaissance plane, the X-15 rocket plane, all those crazy things that you've investigated, if you've ever looked into the history of space, they were all furnished with Accutron timepieces, watches for the astronauts, and also dashboard-mounted clocks. Just the same as that watch I showed you. So in a moment, I'm going to show you these guys land on the moon. And the part of the timing was this was with Accutron clocks.
So now we're critical fuel state. And that's why the 60-second call was given. And then the 30-second call.
Then I really got nervous, was calling out 25 seconds of fuel left. And then 20 seconds of fuel. Oh, jeez.
Okay, engine stop. ATA at a descent. Mode control both auto. Descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground.
Anybody as old as I am or older knows that those words were fascinating words. The Eagle has landed. That's the first time humans actually landed on the moon. That was an earth-changing, life-changing event. An amazing technological achievement. And part of that technological achievement was done with that amazing Accutron watch, all based on sound. I really hope you've enjoyed the video, and I hope you have a lovely night. Good night.